Okay, so today's lesson in the Driving Safely series is on speed, distance and time. Now, this is something that you are all going to have no problems with because we have done quite a lot of work recently on speed, distance and time and using our speed, distance, time formula. But the most important thing I want you to understand first of all is, do you know the common speed limits, which I'm pretty sure you know them better than me. So we have our school zone of 40 kilometres per hour, our residential areas, it's 50 kilometres per hour, and that's not on my sign here. My city streets are 60. We have 70 kilometres per hour, 80 kilometre per hour zones. The highway is usually 100 kilometres per hour. And if you get out on the open road, some motorways are even 110 kilometres per hour. So that is pretty handy to know. But the most important part of this lesson is being able to use our speed, distance and time formula, which is just here, and which I'm pretty sure that you all know how to use very well. So that's why I haven't done very much work in this. I have one question, and then you've just got a whole stack of work that you need to get done in your textbook, from your textbook, I should say. So here is the one and only question you guys are going to get. Bella left home at 6 a.m, so that obviously looks like that needs to be something important. Let me get my pen up for you. And this is what you need to do in a test as well. Underline what is important. Bella left home at 6 a.m. to travel from Sydney to Brisbane, and that's a distance of 1,027 kilometres. She stopped for meal breaks and fuel and arrived in Brisbane at 8:30 p.m. So that's something else that's important. So the first part of it says, what was her average speed for the trip, correct to the nearest kilometres per hour? Well, we all know that lovely speed formula. Speed equals distance over time. So we're obviously going to need to use this. Now the distance, what are we told? We are told the distance, and we're told it is 1,027 kilometres. So that's the first part, that's easy. We need to know time, slightly more difficult, but I'm pretty sure you can all work out the difference in time between 6 a.m. and 8:30 p.m. And what you get is that is 14 and a half hours. I'll just write that as 14.5. You can see I am still struggling with this pen. Okay, so 1,027 divided by 14 hours 5, and our calculator is an amazing thing, and it gives us something like 70.8275. And we have a quick read. Have we answered this? No, it says correct to the nearest kilometre per hour. So if the nearest kilometre per hour must be 71 kilometres per hour. And that's very messy, but hopefully you can read that. So let's try and do the next part, D. B, I can't even write, nor can I talk today. How far to the nearest kilometre could she travel at this speed in 50 minutes? So we are told, well, we already know the speed because we just worked that out. That's 71 kilometres per hour. The distance is what we're trying to find. We've been asked what is the distance. We're told the time. The time is 50 minutes. Now this is in minutes, and our speed is in kilometres per hour. So we really need to change our time into hours as well. So if I was to change this into hours, I would simply divide it by 60, and that would change it into hours. So that's 5/6 of an hour. So now we can use our distance, speed, time formula, and we can rearrange it. So we have speed equals distance over time, but we actually want distance by itself. So if we times time to both sides, those times cancel. So speed times time equals distance, or we can just memorize that. So my distance is going to be my speed times my time which is 5/6 of an hour. And I'm pretty sure you get something like 59.166, something along those lines. And what we need to do is it needs to be to the nearest kilometre, because that's what it says in our question. So to the nearest kilometre, we need to fix this up. And to the nearest kilometre, that's got to be 59 kilometres, I should say, because I'm trying to find a distance, aren't I? So that was really nice and easy. Let's see if we can go on to the next one. Last part, part C. How long in hours and minutes would it take her to drive 864 kilometres? So let's have a look at part C. So for the last part, we're told the distance, 864 kilometres. And we know the speed because we worked that out in the first question. That's 71 kilometres per hour. And this is just easy because it's our speed equals distance over time formula. The question is we're trying to find time. So if I multiply both sides by time, I get time and speed equals distance. And we want time by itself, so I can divide both sides by the speed. So time equals distance over speed. But you should be able to do that by yourselves without having to do any of this working out. It's up to you. So time is the distance, 864 kilometres, over the speed, which is 71. And your calculator gives you 12.169. Now the question wants your speed in hours and minutes. This is not in hours and minutes, and you should all be thinking about what you have to do, and you have to find your bubble key on your calculator. It's a fantastic key, it does so much for us, and it gives us 12 hours and 10 minutes. And we've answered the question. So I'm pretty sure that you have no trouble with this. If you do, you know where I'll be. Thanks for listening.